Welcome to our review of the National Plumbing Code, specifically focusing on venting notes. Venting is a critical part of any plumbing system, ensuring that water flows smoothly and sewer gases stay out of the building. Let us dive into the different types of vents and how to size them. We will start with the simplest vents, individual and dual vents. For these, you do not need to calculate pipe length or fixture unit loads. Their size is strictly based on the size of the trap they serve, using Table 2.57.1. Notice that for a dual vent, which serves two fixtures, you always base your sizing on the larger of the two traps. This ensures the vent can provide adequate airflow for the maximum potential drainage.
Relief vents also ignore length and fixture unit calculations. However, sizing them requires checking two specific rules. First, they cannot be more than one size smaller than the circuit vent they support, though they max out at a 2-inch requirement.
Now we move into more complex territory. Circuit, continuous, and branch vents all require you to calculate both the length of the pipe and the total hydraulic load, or fixture units. You will use Table 2.5.8.3 to determine their minimum sizes. A crucial detail for branch vents, when calculating the fixture units, you must count all fixtures that get their air supplied by that branch. This even includes fixtures attached to relief vents, which normally do not carry a fixture unit load on their own.
Stack vents, vent stacks, and vent headers are the major arteries of your venting system, terminating in open air. For all of these, your fixture unit load must account for the primary drainage load, plus any secondary vented fixtures.
A very common mistake is forgetting the emergency floor drains. You must always remember to add the venting fixture units from any 2-inch emergency floor drains into your total load calculations for these major stacks and headers.
Let us clarify floor drains, as they have specific rules based on size and purpose. 2-inch emergency drains do not have a drainage load, but they absolutely require a venting load. Conversely, 3-inch emergency drains require neither.
Be careful with 3-inch or larger non-emergency drains. While they typically do not need a vent, if they fail to meet the specific requirements of Section 2.5.1.1/3, such as exceeding maximum trap arm lengths, they must be vented just like smaller fixtures.
Understanding how vents combine is easiest when visualized as a hierarchy. At the base, we have our foundational vents: individual, dual, relief, continuous, and circuit. Any of these can run independently to open air, or they can combine. When you join any two of those foundational base vents together, they become a branch vent. Furthermore, if you join two branch vents together, they simply remain a larger branch vent. Moving up the pyramid, a stack vent or vent stack retains its name until it either reaches open air or joins with another stack. Once two or more stacks combine, they form the top of our hierarchy, a vent header. Everything flows upward to the header and out to the open air. This is Table 2.5.7.1, the fundamental sizing chart for basic vents based on trap size. Notice that for trap sizes ranging from 1.5 inches all the way up to 4 inches, the minimum permitted vent pipe size is 1.5 inches. Always reference this table for individual and dual vents. To wrap up, remember the great divide in vent sizing. Basic vents, like individual and relief vents, never require length or load calculations. But once you move into branch vents, circuit vents, and stacks, you must calculate total fixture units and pipe lengths. Keep these rules in mind, and your venting systems will always meet code.